Hi, this is Valerie Musica, and today I will be explaining the sliding filament theory. So as we know, when the muscle cell is in a resting state, the two strands, myosin and actin, will not be in contact with each other until a nerve sends a message to our muscles, which enacts the sliding filament theory. As ATP binds to the myosin head, the myosin head detaches from the actin, putting it in its resting state. As time moves along, however, this ATP molecule splits into ADP plus a phosphate during the process of hydrolysis. This therefore allows for the myosin head to now bind to the actin because the energy was converted to do so. With actin and myosin being in the right positions to do so, a cross bridge forms at this binding site on the actin. In order for the binding sites on the actin to be exposed, calcium ions bind to the troponin. This binding of calcium ions therefore allows troponin to change shape and rotate around the actin, which then leaves the binding sites exposed for this myosin head to bind to the actin. During this cross-bridge process, the contact allows the myosin head to bind toward the center of the sarcomere, which shortens the overall length of the muscle, resulting in a muscle contraction. Once the nerve stimulus is no longer present, the calcium ions diffuse back into the sarcomere. Furthermore, the troponin and tropomyosin will return to their resting state, and an ATP molecule will attach to the head of the myosin. The energy released by the ATP molecule allows for muscle relaxation to occur. The myosin head is then released from the actin, which covers up the binding site. And once the ATP molecule is in place on the myosin head and the calcium ions are present, then the cycle can continue. And here we are. As you can see, the ATP is now binded to the myosin, and then the whole process can start again. Thank you for coming to my video about the sliding filament theory.